So the compound interest is slightly different from the simple interest. It's a lot more widely used in real life. Not as much as what we're going to talk about in the next lesson, which is annuity, but this is the basic of that. So the compound interest means that it calculates the principal amount plus the interest. So this is the total amount. It calculates the total amount by applying the interest rate to the previous amount in the account. So in the simple interest, the interest rates were only applied to the principal amount, which was the initial money. However, in this case, it will be applied to the money in the previous year. So this interest rate will be applied to this one. So I am going to put money 1. Okay, that's the 1 year after money. And then obviously that is more than the blue money in this case, right? Now then after the second year, this interest amount from the first year to the second year will be applied to this money 1, and that becomes, let's say, money 2. So whatever the interest per that year will be applied to your previous year, right? Not the previous year, but just the previous year. So then when you actually do all the compounding in this case, so you're compounding every single thing. So here then you're going to have another one applied to this, and you're going to have, let's say, money 3. And then for this one, you're going to have this interest rate applied to the money 3. So then it becomes money 4. Okay. Now this is compounding. Hopefully you can notice that, oh, this is geometric sequence. It is actually geometric sequence and actually geometric series at the end. Now the formula is a slightly different from, not slightly, a lot different from the simple. So in this case, A, which is the total amount, equals P, the principal amount, times 1 plus R, the interest rate, divided by C, the compounding period, close M to the power of the time, which is the year. Did I put it? Oh, yep, I did. This is per year times the compounding period. Okay, and the interest amount then is obviously total minus the principal. So, oh, by the way, your textbook may say it is 1 plus R over N and then Tn. Now N, C, they're the same thing. I just chose C because I don't know, to me it feels more natural because it represents compounding period, right? It starts with a C rather than N. That's why. Now, so an example is this. Now, Mr. Whomever invested $100,000 to an investment account that gives 3% A. Now this actually read it as 3% per annum. It means 3% per year, compounded annually 50 years ago. Now today is the end of the term. Hooray! And he wants to withdraw the money. How much will he have? How much is the interest he earned? So first it says compounded. So whenever it says compounded, then it's not simple. It's definitely a compounded or something called annuity later on, but there's a huge difference between. Now, then it says compounded. So let's say it's a compounded interest. So then the formula is A, the principal amount, which is 100,000, and then 1 plus R, which is then 0.03. Now remember, this R is rate per year. Okay, make sure you follow it, the rate per year. Now, divided by the compounding period. Now, this says compounded annually. So if it is annually, then it only compounds once, so your C will be 1. So C basically represents how many times it compounds per year. And then it says 50 years, and the C is still 1. So then your calculation becomes 100,000, 1 plus 0.03, to the power of 50. I'm not sure whether my calculator will do the work, but let's actually give that a try. So, oops, not 50,000. So $100,000 and 1.03 to the power of 50. Now then it gives me around 438,390.60. So the total amount after 50 years, I get $438,390.60. So your interest amount then will be the total minus the investment, the principal amount. So this becomes $338,390.60. Okay. Now then, the next example is Mrs. O plans to invest $50,000 to an investment account that yields 5% per year, compounded quarterly. Now, as you can see, it says compounded, therefore it is compound interest. Now, as quarterly, so it means every year it compounds 4 times, so C will be 4. Now, for 25 years. Now, A, how much will be the total money after 25 years? Okay, so then your total amount is then $50,000. Well, it's not yours, my wife's. And there will be 1 plus 0.05 divided by, then quarterly, so divided by 4, and then 25 years, which is T, times C, which is 4. So this then becomes $50,000, 1 plus, now 0.05 divided by 4 is 0.0125 to the power of 100. Now, you may ask me, should I really write this step? No, not really. Okay, all I need is this one, and to the final answer, I'm completely okay. However, if you make a mistake and you don't have the same answer as mine, or somewhat very close to, then you're going to lose a lot of marks because you don't show me any work. But if you show me all the work, all the steps, then you're only going to lose a fraction of it. Now according to the calculator, $50,000 times 1.0125 to the power of 100. Ooh, 125 to the power of 100. Now then, this gives me 173,170.21. So then the 25 years later amount is $173,170.21. Now then, B, how much will the total interest be? Well, it will be just I equals the interest amount, then my wife's initial will be taken out from the total amount. So this case is, oops, wait, 50,000, and that will be $123,170.21. So the 25 years worth of the interest is then $120,170.21. Okay, so be careful with the word compounded and whatever the compounding period. If it is quarterly, C will be 4. If it is bi-weekly, C will be 26, etc. Okay, the calculation itself is actually quite simple to do. Now then, the big question is, which way of the calculating interest amount between simple and compound is a better option if we invest? Well, I'm speaking really, really fast. Which way of calculating interest amount of a loan do you think a bank will use between simple and a compound interest? So think of this way, right? The question is, which one actually produces more interest? So for us, when we are investing, obviously we want to get more money, which it means that we need more interest. Whereas if we are borrowing money, or if you're lending money, let's assume that you're a bank, if you're lending money, obviously then you want to charge more interest, right? So then the question is, simple versus compound, which one makes bigger number in terms of the interest amount? So let's actually take a look at the first case. So case 1, Mr. O, who doesn't know a thing about investing money, wants to save up some money by investing his money into an investment account for 40 years. The accounts that he is interested in are account A, 10% per year of interest yield. Now there's no compounding, so it's basically simple. It doesn't say anything about compounded here and there. Now, account B then says 10% per year compounded weekly. So it says compounded weekly. That means it is compounding interest. Now, both has the same interest rate per year. Now, the principal amount is $5 million, which is kindly donated with hidden dark intention by his bright grade 11 you guys, math class students. Now, his only intention is to withdraw the money after 40-year term. No withdrawing before the term ends. Okay, there is no other withdrawing money. So it's just you put it in, and then that's it. You are only touching the money after the 40 years in this case. So he will put the money into the account at the beginning, and then there won't be any additional deposits to an account. So I won't make any other additional deposits. I'll just put that $5 million into the account, and I'll just forget about it after. And then after 40 years, I become super rich. Now, assume he's going to live more than 40 years. Please don't say that I will die in 10 years, okay? I will live more than 40 years so that I will enjoy that money. So don't even consider what if he dies before that. I think I know who's going to say this, to be honest. Now, then, the dumb math, Mr. O seeks for advice on which one he needs to invest into for more money, account A or account B, or does it really matter? So let's then take a look at it. So all we need is for the account A, we calculate interest. Now, since this is a simple, we're going to use the I equals PRT. So the interest amount is going to be $5 million. I will just use zeros. So $5 million. Using a comma actually can be very effective for you too. The rate is 10%, so 0.1. Now per year, and then it's 40 years. Now using this calculation, I get 5 million. Whoa, I put too much. Okay, 5 million times 0.1 times 40. So I get, how many zeros? I get a lot. I get $20 million as an interest. Okay, that's interesting. Now then the account B, since this is compounding, and it will be A equals P1 plus R over C, and then T times C. Now the principal is $5 million. 1, 2, 3, 4, 5, 6. And then 1 plus 0.1. Now it says compounded weekly. So there are 52 weeks. Therefore, it's compounded 52 times a year. And then it will be 40 times 52. So according to the calculation I have, it will be $5 million times 1 plus 0.1 divided by 52, and then to the power of 40 times 52, and I get, whoa, how much is this? 271,944,141.33. So let's put the comma so that I know. So I have 2 billion. No, this is not 2 billion. 271 million, I think. So it is $271,944,141.33. So my interest amount in this case will be this amount minus my principal, which is 5 million, right? And that gives me, so minus then 5 million, and it gives me 266,944,141.33. Now, this is $266,944,141.33. So, if you do the math, which one's bigger? Obviously, the winner is account B, right? So, the winner, account B. So, it seems like our hypothesis could be compound interest compound interest yields more than simple interest. Right? Here we only have $20 million. Here we have about 13 more times. So then what I want you to do is I want you to try case 2 on your own. Now here's one small thing that you have to fix. Option A is supposed to be blue pill. The option B is supposed to be the red pill. Well, if you already know what I am going into by listening to blue pill or red pill, hopefully you understand what I am going through. Kind of cheesy question that I just created, but hopefully you guys can enjoy it. Okay, so after case 2, let's see whether you can do this on your own, and we will do it together. Okay, so hopefully the video was easy enough to follow. Nice sound, a nice video, and hopefully you guys enjoyed it. All right, so see you guys on next class. See you guys next class. I don't know what class is next class. Okay, bye guys.